Good morning, everybody. It's Friday the 1st of May, so we'll go over some more past paper questions, so we'll get started. Okay, so first one here is the vertices of a triangle A, B and C are shown. The broken line represents the altitude from C. So there's the altitude coming from C and it meets the opposite side at 90 degrees. Now, before I start this question, I've put in the coordinates. Always do a double check and make sure you've got them correct. -1, -5, 13, 3. Now you should always do that so you can see exactly what you're doing. Right, so we want to show that the equation of the altitude from C has that equation. So we have to work out the equation of the altitude. So on the altitude, you only ever know one point, and that's that point there. So I can't work out the gradient using y2 minus y1 divided by x2 minus x1. So I use the fact that it's perpendicular to the opposite side. So I'll make my statement, gradient of AB multiplied by the gradient of the altitude is -1. So we'll now work out the gradient of AB. So gradient of AB is y2 minus y1 divided by x2 minus x1. So I'm going to take this as my second point. So I've got -5 minus 7 divided by -1 minus -5. So that gives me -5 minus 7 is -12. Divided by 1 plus 5 is the same as 5 take away 1 is 4. So the gradient of AB is equal to -3. So therefore gradient of the perpendicular bisector, it's not a perpendicular bisector, it's an altitude. So gradient of altitude is equal to, flip it and change the sign, is equal to 1/3. Right, so now I want to get the equation of that. Now I can get the equation because I know a point and I now know the gradient. So gather your information together. So the point that I know is the point C, the only one that's on that altitude. So we've got the point 13,3 and I've worked out that the gradient is equal to 1/3. So y minus b becomes y minus 3 is equal to m, which is 1/3, times x minus a, which is x minus 13. Now I don't like that third, so I'm going to multiply the opposite side by 3. So that gives me 3y minus 9 is equal to 1 lot of that, which is just x minus 13. So we don't want that -9 to be there, so I'm going to add 9 onto both sides. That gives me 3y is equal to x, and I've got -13 and I want to add on 9, so that gives me -4. Now we to prove that it was the same as that. Now what's the difference between those two equations? The difference is that they have rearranged that. So they've got the x's coming first, then the y, and then the 4. Okay, so we want the plus x. So plus x is on that side, so I'm going to leave it there. I want to bring the y term over beside it, and I want the 4 on opposite side. So I'm going to take 3y off both sides, so that would be 0 is equal to x minus 3y minus 4. But if I read it round the other way, that would be x minus 3y minus 4 equals 0. And if you compare the two equations, the 4 is on the right hand side, so x minus 3y is equal to 4. So the equations are both exactly the same. Okay, so we've proved that one. So for part B, we want to find the equation of the median from B. So the median from B, and I'll draw that in, is a line that comes from a vertex and it hits the opposite side bang in the middle. So that side there is exactly the same as that side there. So therefore, that is the midpoint of AB. Right, so what we want to do then is we want to work out the midpoint of AB. So that's the coordinates of M. So add the 2x numbers together, divide by 2, add the 2y numbers together, divide by 2. So -5 plus 13, that gives me 8, half of 8 is 4. And 7 plus 3 is 10, half of 10 is 5. So that midpoint there is coordinates 4, 5. Right, so we want the equation of that median. I now know 2 points on it, so I can work out the gradient using y2 minus y1 divided by x2 minus x1. So I'm going to take that as point 2. So it's going to be y2 minus y1 divided by x 2 minus x1. So that gives me 10 divided by 5, which is 2. So the gradient is equal to 2. Right, I now know the gradient and no point in the line. So the equation of the median is y minus b is y minus 5 is equal to m times x minus a. So therefore y minus 5 is equal to 2x's minus 8. Add 5 onto both sides, so y is equal to 2x's minus 3. Part C, find the coordinates of the point of intersection of the altitude from C and the median from B. So the altitude from C had equation x minus 3y is equal to 4, and the equation of the median from B was y is equal to 2x minus 3. Right, now I want x is to come first, y is to come next, and equal to a number. So that 2x is in the wrong place, so I'm going to take 2x off both sides. So minus 2x's, I'll keep the plus y where it is, and the minus 3 can stay where it is. Now we've got to solve those simultaneous equations. Okay, now we need to find something that's going to eliminate. So look at the x's, not really, both get different signs, so we could eliminate that or we could eliminate that. Right, so what I'm going to do is I'm going to make that top equation 2x, multiply it all by 2, and then the x's will cancel. Okay, so times the first equation by 2, so x times 2 is 2x's, and that would be minus 6y, and that is equal to 2 4s are 8. Bottom equation will leave as it is. And we'll now add both those equations. So I'm going to add both of those equations together. Do the x's first. So 2x take away 2x is 0, that disappears. Minus 6y plus y is minus 5y. And that is equal to 8 plus minus 3 is 8, take away 3 is 5. So y is equal to 5 divided by minus 5, so y is equal to minus 1. So we'll now sub y equal to minus 1 and 2, and it doesn't matter really what equation, I'll just take the top one. X minus 3y is equal to 4. So x minus 3y is minus 3 times minus 1 is plus 3. That's equal to 4. Take 3 off both sides, so x is equal to 1. So the point of intersection of those two lines, x coordinate comes first, is 1, and the y coordinate is minus 1. Okay, for this one it says find the equation of the line passing through the point which is parallel to the line with equation. So we need to read off the gradient of this one, parallel lines of equal gradients. That's not in the correct form to read a gradient off because it's got to be y is equal to mx plus c. So that's in the wrong place. So we'll take 4x off both sides, so y is equal to minus 4x's plus 7. It now is in the correct form, y equals mx plus c. So m is equal to minus 4. Now make your statements, it's parallel, so parallel lines have equal gradients. So you can just write down m1 equals m2. So therefore m2 in this case is also equal to minus 4. And we know that it passes through the point 2, minus 2, 3. So we can go straight and work out an equation. So y minus b is y minus 3 is equal to m times x minus a. So x minus minus 2 is x plus 2. So y minus 3 is equal to minus 4x's minus 8. So y is equal to, add 3 onto both sides, minus 4x's, and that would be minus 5. Okay, so triangle PQR, diagram shown. We want to state the coordinates of M, the midpoint of QR. So there's Q and there is R, so we want the midpoint of that. So coordinates of the midpoint of QR, we'll call them M. Add the two x's together, divide by 2, add the two y numbers together, divide by 2. So minus 6 plus 10 is 4, half of 4 is 2. 2 plus 6 is 8, half of 8 is 4. So that point in there is a point 2, 4. Put them into your diagram so you keep track of what you've done. Right, so we've got that one. It says hence, so that means use information you've just got. So hence find the equation of PM, the median through P. So PM is that line there. So I want to find the equation of PM. That's the median. Now I know 2 points on that line, so I can work out the gradient. So the gradient is y2 minus y1 divided by x2 minus x1. So I'll take this as 0.2, so minus 4 divided by 0 minus 2. Right, so that gives me a gradient of, and work out top line, minus 8 divided by minus 2. So the gradient of that one turns out to be 4. Okay, we know now the gradient, we know the point in the line, so the gradient is 4. A is 2, B is 4. So y minus b is y minus 4 is equal to m times x minus a. So therefore y minus 4 is equal to 4x's minus 8. Add 4 onto both sides, so y is equal to 4x's minus 4. And that's the equation of your median through P. Okay, part C, we want to find the equation of the line L passing through M and perpendicular to PR. Right, so if it's perpendicular to PR, we know that the product of the gradients, M1 times M2 is minus 1. So the first thing I need to do is get the gradient of PR. So gradient of PR, it's those 2 points I'm using. So gradient of PR is 6 minus 4 divided by 10 minus 0. So that turns out to be 10 divided by 10, so the gradient of PR is equal to 1. So we want the line that's perpendicular, so the perpendicular gradient, and that's what you sign for perpendicular. Remember, two gradients multiplied to give you minus 1, so it's got to be equal to minus 1. Now somewhere write that down, M1 times M2 equals minus 1. So that's there for the gradient, it's got to be equal to minus 1. Right, so it passes through the point M, and we've already worked out M is 2, 4, so I've got a gradient of minus 1, it's passing through the point 2, 4, so y minus b is y minus 4 is equal to m times x minus a. So y minus 4 is equal to minus x plus 2, add 4 on to both sides, so y is equal to minus x's, and that's going to be plus 6. Last part of this question, it says show that the line L passes through the midpoint of PR. So do we know the midpoint of PR? Not yet. So I'm going to work out the midpoint of PR. So midpoint of PR. Right, so add the x's together is 0 plus 10 is 10, half it is 5. Minus 4 plus 6 is 2, half of 2 is 1. So we've got to show that the point 5, 1 basically lies in that line. Y is equal to minus x plus 6. So the rule is then, if I take the y coordinate, it should be equal to minus x coordinate plus 6. So we'll do that side. Y is equal to, so what's y? The y coordinate is 1. Y equals 1. And the y coordinate will work out what it is on here. So y is equal to minus x plus 6. And minus x is minus 5 plus 6. So minus 5 plus 6 is also equal to 1. So that and that are the same. So therefore the point lies on the line. Okay, so A is the point, B is the point, C is the point. The vertices of a triangle, find the equation of the median through C. So I'm going to draw the median through C. So median through C comes from C and it meets the opposite side in the middle. Okay, so that's about the median there. Now, if that is the median, then that side is the same as that, and that's the midpoint of that line. Okay, so we want to find the equation of this median. So the first thing I do is I've got to work out the midpoint of those 2 points there. So we've got minus 3 and 7, so add them together and divide by 2. So minus 3 plus 7 is 4, half of 4 is 2. And 7 plus 9 is 14, half of 14 is 7, so it's a 0.27. Now we want to find the median through C. Right, so right away I can see that the x-coordinate there is 2 and also the x-coordinate there is 2. So really that is a vertical line. Vertical lines have equation x is equal to a number. So the equation of that is x is equal to 2. Now, if you don't spot that, the first thing you'll do is you'll work out the gradient of CM. So I'll do it. Right, so this is a big OR. Gradient of CM is y2 minus y1 divided by x2 minus x1. So it's 7 minus 11 divided by 2 minus 2. So 7 minus 11 is minus 4 divided by 0. So as soon as you see that, you cannot divide by 0, so the gradient is undefined. So when the gradient is undefined, it tells you that you've got a vertical line, and all vertical lines start off with equation x is equal to a number, and then you look at one of the points on that line to find out what that number is. So it's 2. If you pick that one, it's 2. And that's your equation. So if you don't spot it that way, you would go through here, but be careful with that. You've got to notice that minus 4 divided by 0 is undefined. Right, so put that into your calculator, it's undefined. A and B are the points, minus 7, 2 and 5a. AB is parallel to the line, determine A. Right, so parallel gradients are the same. So therefore, there's an unknown here, I need to work that out, but if I know what the gradient is, I can work backwards. So it's got the same gradient as this line, so we'll work out what the gradient of that line is. So 3y minus 2x's is equal to 4. That does not look like y is equal to mx plus c, so I cannot read the gradient off from that. So 3y is equal to, add 2x onto both sides. I don't want 3y, I only want 1y, so y is equal to 2 divided by 3, 2/3 x, plus 4 over 3. And the gradient then of this line is equal to 2/3. Now, it said that it's parallel, so make your statement parallel. So M1 equals M2. Right, so the gradient of this line then is, it's got to be equal to, we'll call it M2 is equal to 2/3. Now I'm going to work out the gradient of AB. So gradient of AB is y2 minus y1 divided by x2 minus x1. So y2 minus y1 is a minus 2 divided by x2 minus x1 is 5 minus 7. Okay, so 5 minus 7, so that gives me a minus 2 divided by 12. Right, so make your two equivalent statements. So that tells me then that a minus 2 divided by 12 is equal to 2/3. Okay, two ways you can do this, and I'm going to do it both ways and you decide which is best for you. So if I've got a minus 2 divided by 12, and that's equal to 2/3, if I want to make that 2/3 out of 12, then I can compare. So if I multiply that by 4, I multiply that by 4, that would give me 4 2s are 8, and that's over 12. But that means that a minus 2 over 12 is equal to 8 over 12. Now compare the two fractions. So therefore, that must mean that a minus 2 is equal to 8. Add 2 onto both sides, so a is equal to 10. Now that's doing it with equivalent fractions. If you want to solve this, think about your sign rule. You cross multiply. So you've got 3 times a minus 2, and that's equal to 2 times 12. So 3a minus 6 is equal to 2 12s are 24. And we want to add 6 onto both sides, so 3a is equal to 30. Divide by 10 to a, divide by 3, sorry, so a is equal to 30 divided by 3 is 10. Both answers are the same. You choose whatever one you find easiest. So in this one, triangle ABC is shown in the diagram. The coordinates of B are, the coordinates of C are. The broken line is the perpendicular bisector of BC. So perpendicular bisector of BC, it hits that right in the middle, and it's at right angles. So we want to find the equation of BC. Right, so, or the perpendicular bisector of BC. So I only know, right now I don't know any points on that perpendicular bisector. So what I'll do is I'll work out the midpoint. So the midpoint, add the two x's together, divide by 2, and the two y coordinates together, divide by 2. So when I do that, I get 3 plus 9 is 12, half of 12 is 6, and nothing plus minus 2 is minus 2, half of minus 2 is minus 1. So I've now got the coordinates of that point there, which is a point 6, minus 1. So I now know one point on my perpendicular bisector. Right, so can't get the gradient, still don't have enough information, so I'll make my statement. So the gradient of BC multiplied by the gradient of the perpendicular bisector is equal to -1. So if we work out the gradient of BC, I can flip and change the sign to get the gradient that I require. Right, so gradient of BC, these two here, so I'll take this as the second point, so -2 minus 0 divided by 9 minus 3, which is -2 divided by 6, always cancel down, is -1/3. So therefore, the gradient of the perpendicular bisector, flip it and change the sign, so it's equal to 3/1, and change the sign is +3. Right, so now I have got a point on the line and I also have a gradient, so I can work out what that equation is going to be. So m equals 3 and the point on the line is 6 minus 1. So y minus b is y plus 1 is equal to m times x minus a, which is x minus 6. Now we want to tidy that whole thing up. So y is equal to 3x's, and that would be 3 6 is -18, -18 minus another 1 is -19. Now I skipped a step, don't you skip steps. Okay, so that's us, we've got the equation of a perpendicular bisector, so y is equal to 3x's minus 19. Part B, it says the line AB, so there's AB, it makes an angle of 45 degrees with the positive direction of the x-axis. So there's the line AB, there's the x-axis, so that angle in there is 45. Now as soon as you see positive direction of the x-axis, gradient is equal to tan theta. That's the statement you make. Right, now I know that theta, the angle is 45, so I know that the gradient is equal to tan 45. So at this stage you need a calculator to do this. Tan 45 is equal to a gradient of 1. Right, so we want to find the equation of AB. So AB, I know the gradient is 1. And I know point B, I don't know point A. So point B is a 0.30. So I've got the 0.30 in there. Now to work out the equation then of that, y minus b is y minus 0 is equal to m times x minus a. And when I tidy that all up, I get y is equal to x minus 3. So that equation is y is equal to x minus 3. Right, now we've got one last wee part to do, which is down here, part C. It says find the coordinates of the point of intersection of AB and the perpendicular bisector of BC. So that's the intersection of those two lines. Right, so we're solving simultaneous equations. Y is equal to 3x's minus 19 and y is equal to x minus 3. Now we want to eliminate one of the letters. I'm just going to eliminate y by multiplying that one by -1. So when I multiply that one by -1, top equation will keep the same. So y is equal to 3x's minus 19. Multiply that one by -1, so minus y is equal to minus x plus 3. Add those two equations together. And when I do that, you can see that the y terms cancel, so that's 0 in there. Then I've got an equals. That gives me 2x's. And minus 19 plus 3 is minus 16. So if we solve that equation to work out what x is. Okay, so read it round the other way. 2x is minus 16 equals 0. Add 16 onto both sides. So 2x is 16. I don't want 2x, I want 1x. So x is equal to 8. Now I want to sub to find y. Okay, so I'm going to sub x equal to 8 into, and it doesn't matter what equation, I'll take the bottom one because it looks easier. So y is equal to x minus 3. So y is equal to 8 minus 3, which is equal to 5. So the point of intersection, x comes first, is 8, 5. Okay, right, so for Monday, we're still not all our way through these past paper questions. We've still got something to do, and it's been quite long doing all of them, but it's worth doing. So for Tuesday. So I'm going to give you until Tuesday, not Monday. Right, so you've got a wee extra day. I want you to do the rest of those past paper questions, and that takes us through every past paper question there is on the straight line. So work your way through those ones, and then I want you to study all the questions we've done, study your notes, make sure you understand it. And on Tuesday, I'll go over those past paper questions. I'll give you a wee quick check your knowledge, and we'll arrange a date where we're going to do a test. Okay, and I'll display a test. I'll give you time to do it, and then you have to be honest and mark it. And anything you don't get right, you'll go back and you will do that. And then we move on to our next topic, which is differentiation. Okay, so work hard over the weekend.